From the Donald Danforth Plant Science Center, HEC-TV, St. Louis Public Radio, and the Danforth Center present Conversations, a discussion about technology, truth, and the public.
Good evening, and welcome to the Danforth Center and our third Conversations event of 2016, third and final Conversations event of 2016. It pleases me, by the way, I'm Hal Burroughs, I'm the chairman of the Conversations Committee, and just so you know that, and a token gets you a front row seat in an otherwise full auditorium. So anyway, but thank you for being here. Thank you also to the Friends Committee and the Conversations Committee for supporting this program and for providing some really good insights into the kinds of programs we should have here for the Conversations events. I'd also like to thank this evening's sponsors, St. Louis Public Radio and HEC-TV. The HEC-TV recording of tonight's event premieres Sunday, December 4th at 5 o'clock p.m. And let's all remember that NFL ratings are down, so by all means. And we'll continue through January on Sundays at 5 o'clock and Tuesdays at 8 o'clock. Let's see, also let me note the thanks for the supportive community and the Danforth Center, so we can not only host these programs, but carry on the center's important work. So during tonight's program, as always, we incorporate Twitter as a means to collect questions for our distinguished panel from the audience, as well as from others who will follow the conversation remotely. And this is my favorite part of the program. For those of you who tweet, please tweet us your question at Danforth Center and view selected tweets on your tweet wall. The hashtag for the event is hashtag CONVOSTL. For those of you who do not tweet, no worry. We will still collect question cards and transfer your questions to Twitter. I have now received 2 tweets, Twitters or whatever they are. One is Twitter is ruined at Hal Burroughs. Can't escape the parents. Hashtag freedom, hashtag Braveheart. That was from. And the other one was, thanks, Hal. So anyway, so the instructions for how this will be accomplished are included on your question card. The use of Twitter is a way to share the discussion and expand awareness of the exciting things happening at the Danforth Center and in our region. Tonight's program is going to have a slightly different format. We are truly excited to introduce Amy Harmon, and in increasing order of importance, Amy is an author and a New York Times national correspondent, a 2-time Pulitzer Prize winner, and a University of Michigan graduate. She's our panelist this evening. I would, and also joining Amy on the stage this evening will be Dr. Jim Carrington, the president of the Danforth Center, who will be joining Amy on stage after her presentation, and I am very confident it's going to be a lively conversation. And we were very excited about this evening's program, and your attendance here today affirms that. So thank you for being here, and Amy.
Thank you so much for the nice introduction. My dad always tells me 2 Pulitzers and a token will get me whatever. So, although we have Metro cards in New York now, so you might want to update the token thing. So thank you for having me. It's so nice to see everybody. And I was asked to talk about truth, technology, and the public. I like to use this Alice in Wonderland, for those of you who haven't read her lately, Lewis Carroll lately. I like to use Alice because if you recall the book, she follows a real rabbit, a white rabbit, down a rabbit hole, and then she gets to a place where it's really hard sometimes to tell truth from reality and what is real. And I think that sometimes in the debates around science and GMOs, that is how I have felt, and many people sometimes feel. You may have heard about this fake news phenomenon. This is not related to GMOs or science, but this is related to politics. And it's been sort of alarming for those of us in the news business to realize that fake news has outperformed real news on Facebook, in the months of the election and just in general, though. It's something that we have to really figure out how to combat, and Facebook is also, I think, trying to figure out how to combat it. This is just a recent example from David Brooks, a Times columnist. They said that he said Trump needs to resign, he prefers to resign or be impeached or get assassinated, which he would never say, right? So his actual quote was, the guy will probably resign or be impeached within a year, but now everybody is saying, oh, David Brooks is saying Donald Trump is going to be assassinated. So it's kind of scary. And to me, it kind of reminded me, though, of, for anybody who's been kind of following GMO stuff or other vaccine-related science news, many of us have seen other sorts of fake news, and it's been hard to tell what's real and what's not, at least for many members of the public who get this kind of thing in their feeds. So this sign says, by the third generation, most GMO-fed hamsters lost the ability to have babies. That was data that came from Jeffrey Smith, who is not a scientist, and it's been widely discredited. So it's just an example, I think, of the kind of images and the kind of news and information that people get from the public. So when you start to think about, well, why do people have, why is there this gap between public perception of scientific issues and the scientist perception of these same issues? I think that to some degree social media, but just media in general and the kind of messages people get, it plays a big role in that. This is a county councilman that I wrote about. He was on the Big Island of Hawaii, where I spent a little bit of time a few years ago because the island was voting about whether to ban all cultivation of GMOs. And I met, this is Gregor Illigan, at a time in that debate that he hadn't made up his mind how to vote. And most of the council had made up their minds, but I went there and I was looking for a story to write, and I found him, and I thought, well, it'd be interesting to follow somebody who actually doesn't know. But he also was influenced by a lot of what he read on Facebook. You just type GMO and everything you see is negative into Google, So, you talk about, well, why does the public mistrust certain things about science? So that's one reason. I've showed you some of these images from anti-GMO activists that are untrue. But we also learned, that Monsanto had been paying or asking academics to take money to sort of make their case to the public, which was disheartening because it ended up making people feel even more like they don't know who to trust. That bothered me because I had written in this story about Gregor Illigan this passage, which was actually what I felt was one of the most important passages of my story, and I'll back up and tell you a little bit about the story quickly. But I made a pretty big deal of the fact that the council members declined to call University of Hawaii scientists who had flown from Oahu instead allotting 45 minutes to Jeffrey Smith, a self-styled expert on GMOs with no scientific credentials. So, I felt like this was a very revealing passage. It showed how the government basically was ignoring science and taking, really people that were uncredible. But then to hear that maybe those scientists had taken money from the industry that we thought they were so objective, it really sort of undermined their credibility. So I called all of the scientists that I'd interviewed for this story to ask them if they had any money from industry, and they all said no. So I was happy to hear that. But I did also have this Twitter exchange with Kevin Folta, who was somebody who's a plant scientist at the University of Florida, who's been very outspoken about the potential benefits of GMOs, and who I had actually spoken to. I didn't quote him in my story. But I was trying to figure out here why Kevin hadn't come forward and said, sort of just disclosed what his, where he was getting money from to travel and to make these speeches. And it was a very interesting exchange. I won't go through the whole thing, but basically his feeling ultimately was that anti-GMO consultants and people are well paid to testify, and he isn't. So he didn't feel like he needed to say that he'd been paid to travel. I just go over that as an example. This is a story that I did that try to debunk a few misconceptions about GMOs. And once you start, I started writing about this subject I guess I started my research for my stories in around 2012. And once you get really immersed in it, you start to think, well, everybody sort of understands it by now. Like, I don't need to repeat the same things. I don't need to debunk things. But I wrote this partly because a really smart editor at the New York Times asked me if she thought these were GMOs, these watermelons. Really, they're just grown in boxes. So, but it inspired us to do another story. Okay, but and I guess I wanted to make the point with this slide that, can I go back? That there's one thing that happens, which is that fake news or fake images get sent around, and it's really just wrong information. There's another thing that happens where academics' credibility has been undermined because we're not sure if they're being paid or not. But there's also just general misconception. People just don't. Average people, smart people at the New York Times who care about food, just don't understand what a GMO is. And I'm using GMOs here. I'm talking a lot about GMOs, but this holds true for other things too. And people still don't understand that vaccines don't cause autism, and they don't totally grasp many scientific concepts. So I find that as I talk to regular people much more than because I get to talk to a lot of scientists who understand a lot, and then I realize the gap kind of every day in my job. So this is some reflections of the public perception of genetic engineering. I wrote about oranges that had a spinach that are being developed that have a spinach gene in order to resist disease, and some of the scientists who are developing it were asked often, will my juice be green because of this spinach gene? No. There's vandalism of golden rice. There's this vote to ban cultivation of GMOs in Hawaii. I'm just trying to give you a sense here of what I think the public perception is. It's probably not news to anyone here, but just to give you kind of the baseline. This is a slide that I usually show. I usually show it, right, to give a dig at liberals, because this is for climate change, for instance. That's been a subject where many Republicans have been the most outspoken to say that humans don't cause climate change, and so I'd like to include this slide just to sort of to say, even though this used to be funny, is my point. Actually, liberals are the ones that are denying established science on genetic engineering. It's been, but now this happened a few days ago. Trump picks a top climate skeptic to lead the EPA transition. So it's not as funny, I feel like, that slide anymore. Like, to dig at liberals, it's just sort of, it loses its kick. I just wanted to mention a few other areas. I think you probably know that vaccines is an area where a lot of people have stopped vaccinating their children. I just read, and I'm not sure of the full context, but that 4 students at Harvard were diagnosed with mumps. So that's a bad sign. And here is a list of some of the divide that exists between the public and scientists. GMOs, genetically modified foods, is way up there. You can see other favor use of animals in research. Is it safe to eat food grown with pesticides? There's just this gap on so many things, including vaccines. Scientists follow public knowledge in media reports, so I guess we're probably going to talk about that. How much of it is my fault? And so I'm just going to talk a little bit about why. So why does this exist? Why is this gap? And this is actually from the movie Frozen. If anybody has children my child's age, she's 12, you might recognize. So this is just my version of the ivory tower, but it's Elsa. Does this ring a bell with anybody? Elsa. She runs away to this tower, and she's very far away from the town folk, and so she doesn't really know what's going on there. I asked on my Facebook right before I came here, I said I want to crowdsource, tell me what some of your pet peeves are about scientists, I asked for my non-scientist friends. And so I wanted to put it in their words rather than my words, because maybe it sounds less threatening coming from them. Scientists can be logistically and common sense, I think he meant logically and common sense challenged, and focused more on advancement and publish or perish, and disconnected from the public perception of them and patronizing about it. I think they believe some of that vocabulary gives them gravitas, importance, helps them get funding. So, I know there are some scientists in the audience, and I have a lot of friends who are scientists, and I generally really like scientists, but I do think that scientists have some self-reflection to do when it comes to thinking about why this gap exists and what to do about it. Here is another example. I asked on Twitter, actually for that story about the square watermelon, what are good examples of foods people assume are GMO that actually aren't? And somebody said wheat. And then Dan Grauer, who is a scientist, said, "Dear morons," including me, "bread wheat is a GMO transgenic of 3 species," and he goes on, right? And so I looked up Dan Grauer. I know him a little bit from Twitter, but this is just in case. I just wanted you to read that tweet again. This is the kind of attitude I think that is a little bit problematic. And I thought I had his credentials in here. So he's at I think the University of Houston. He's a well-known scientist. He's won some awards. So that's kind of the representation that feels a little bit alienating for people who are just trying to figure out what's going on here. Another thing about scientists. This is an example of a paywall at a scientific journal, and the article is. Sorry, I can't even read my own, but it's an article that I think people might actually want to read. It has to do with the science that's linked to torture and human experimentation. But I could have chosen many article subjects. The point is here that it's behind a paywall, and the public really can't get access to it. So I think that scientific publishing and the way it's worked for many years and the way that scientists seem to like it to work is also kind of a problematic thing for trying to get the public. If you really want the public to understand science, I feel that scientists might consider making their science more accessible to the public. And I wrote about that here because in physics, actually, that's much more the case. Physicists deposit their papers in a public archive, and biologists are just beginning to think about doing that. So I wrote about that, and a couple of Nobel Prize winners actually have started to make their articles publicly and freely available. Here's another reason I kind of feel like scientists don't really care that much about communicating with the public. There's this thing called ethical, legal, what is it, Elsie, it's ethical and legal science implications. And at a Cold Spring Harbor laboratory meeting where I was, everybody just kind of left. Because when we start to talk about how science really does connect to the public, I feel like scientists, I understand they have a lot of science to do, and they want to talk about science with each other, but they sort of give short shrift to the human implications of their science. I will speed through the rest of this because I also really want to have this conversation with Jim. But I think that this is a new area called gene editing, which I know the Danforth Center, I got to see a little bit of gene editing that the Danforth Center is doing on plants today, which is pretty exciting. But it's also being done on animals. These dairy cows, as you probably know, are born with horns, generally. And the horns are burned off because the cows will hurt each other and their handlers if they're not burned off. But a company has figured out a way to edit the genome of these cattle so that they don't have horns, so that they're born without horns, which is cool. I mean, I think that's a really interesting application of, it's done not with CRISPR, which is kind of the gene editing tool in vogue, but another tool called TALENs. The thing that I wanted to mention about this, though, is that they're eager to have this completely, to not be regulated. And I think it's just going to be a coming issue where I think this is a really interesting question to think about going forward, is whether the public is going to feel like people are trying to get around, companies are trying to get around them again by not really revealing what is gene edited and what isn't. And the reason it wouldn't be regulated is that they're just using a little bit of DNA from beef cattle to put into the dairy cattle. So that could theoretically happen in nature. They're not putting in a trans gene from another species. So it's unclear how these new GMOs are going to be regulated. People don't even want to call them GMOs. They want to call them like precision breeding products, which do what you want, but I don't know. Okay, so I'm just going to quickly play a little clip from Jimmy Kimmel, and then I'll be done. If I can figure out how to do that.
According to a new study that was done by Consumer Reports, a majority of packaged goods that are labeled natural are actually contain genetically modified ingredients, which makes it unclear, as to whether they are natural or not, because they grow, but they've been modified in a laboratory or whatever. Apparently, the FDA will allow companies to put the word natural on a product label as long as it says JKLOL on the back of the product. But critics of genetically modified organisms, or GMOs, claim that they pose health risks. It's a complicated issue, though, because there isn't a lot of evidence to back that up. Still, some people are dead set against them. There's been legislation designed to limit GMOs. You see documentaries and angry Facebook posts about it. How many of you do not want GMOs in your body? Yes? Okay, a lot of people. All right. So, as I usually do, when people take a stance on a complicated issue, I wondered how many people who are against GMOs really know what they are. So we sent a crew to one of our local farmers markets to ask people why they avoid GMOs, and more specifically, what the letters GMO stand for. Enjoy.
Do you try to avoid GMOs in your diet?
I do. Yeah.
Tell me why.
There's just a vibration with GMOs. For me personally, just something that I don't particularly want to put into my body.
What does GMO stand for?
Genetically modified. Genetically modified.
Yo.
The.
Oh.
I don't know.
Bishop Don Magic Wand, what is a GMO?
Well, I'm not really sure. You have to make me familiar with that. What is a GMO?
Do you try to avoid GMOs in your diet?
Yeah, absolutely.
Why is that?
Just the effects, I guess, on myself.
What does GMO stand for?
Oh, man, putting me on the under the grill. Let's see. I don't even remember.
Do you try to avoid GMOs in your diet?
Absolutely,
Why?
because they're not good for you.
What is a GMO?
It's genetically I don't know, what is it?
If you are eating whole foods, you want to eat what you're eating.
Okay. All right, it goes on. I didn't want to run the whole clip. And I play that, so I laughed when I saw that, and you also laughed. But I actually play that as an example of the kind of condescension that I think that both journalists and scientists and also comedians. I mean, it's not Jimmy Kimmel's job to communicate science to the public, so I can't really implicate him in any wrongdoing there. But I think that making fun of people or sort of condescending to people or dismissing people who don't understand what you're talking about is not the way to go. And I'll just end there. I'll just say one last thing, which is that you might say, well, what is the way to go, Amy? And my way is to try to find stories. And I won't go through these stories because my time is up. But I try to find stories that are narrative stories that aren't just trying to hit people over the head with science, which I don't think always works, but to try to incorporate them into something that people can emotionally identify with, like the journey of that councilman that I mentioned in Hawaii, his journey to understanding and ultimately deciding to vote against the ban on cultivating GMOs. He lost, and that decision is now being challenged in court. But So that's my deal. I try to write stories to communicate science as best I can. Thank you.
You just covered everything I had here.
All right, we can go.
So what do you want to talk about?
Well, I have quite a few questions for you. Would you like me to start?
Whoa, who's the journalist here? We did not set that up. We didn't. No, I've got a lot of things I want to get to, and it's pretty much deep diving into all the different things you just raised.
Okay.
But first, I want to hear more about what you are. Are you a science journalist? Are you something else? How do you describe yourself?
I don't describe myself as a science journalist, although I write about science. I always feel like I'm sometimes represented as a science journalist, and I feel slightly fraudulent about that because people are expecting me to have written stuff about studies in journals and to know more than I do necessarily about every scientific subject out there. But I'm just a plain old journalist. I'm a reporter. I don't even.
But you're doing such a great job communicating about science. So what are you doing that so many other journalists who are writing about science or science journalists, what are you doing that they're not doing?
Well, thank you. I mean, I should say, I think what a lot of science journalists do, I have a lot of good friends who are science journalists, and I really admire what they do. And science journalism covers a whole range of types of stories. But I think like a prototypical science journalist is somebody who might report a lot on the latest scientific studies. So they will read Science and Nature and all of the journals and sort of pick out the things that they think will be most relevant to a general reader, and they'll translate them beautifully, right? So I read. I'm sure we all read some of those stories. I don't think that's my forte. I think a lot of people.
What is your forte? How do you describe what you do?
I look for a way to, I guess, to storify a scientific trend, or I look for intersections between science and real people and try to write about them in a way that people will emotionally connect with. Usually that means finding a narrative way to tell a story. So it's not just here's what some people say and here's what other people say, and this happened, and here I'm going to get some people commenting on it. It's usually something that I try to find a character, a protagonist, for example. Gregor Illigan is a good example of that. Somebody who I can follow over a period of time, because I think the best stories that we can think about are stories that where somebody is somewhat transformed, and it takes time for somebody to transform. I mean, so it's hard. I mean, I wrote, I guess another example might be about a young man who has autism, who is coming of age, and my goal there was to say, well, we know a lot more. Science has told us a lot more about the underlying causes of autism, how to teach individuals with autism. That vaccine doesn't cause autism. Vaccines don't cause autism. But we're dealing now with this larger group of identified people with autism coming of age, and how will we deal with that as a culture? So, but my point was, I followed him for 2 years. That wasn't the only thing I did, but I did follow him for 2 years. So that's my approach to reporting, and it's time intensive.
And so in reading your work, there are so many interesting people out there who are influenced by or affected by science. That's maybe what I pick up, and that's why they're so interesting. You're not writing about science, you're writing about people who are experiencing science, or the effects of science, or the challenges with some of the public perception.
Exactly, yes.
You wrote a really nice piece, and you referred to it, on citrus greening in Florida. And I think even though we read about it, I think most people here could say something about citrus greening. But I think relatively few people know the magnitude of this problem. But you focused on the farmers, the orange farmers, and what are they going to do? What are they going to do when the citrus industry gets decimated?
Yeah.
Because that's a real possibility.
There are 75,000 jobs that depend on the citrus industry in Florida, and we get, I think it's 80% of our orange juice, Americans, the juice we drink for breakfast is from Florida. I think most people have kind of identify with orange juice. In that case, I was looking for a way to write about genetic engineering in a counterintuitive, to kind of raise these points that I knew or I had learned. I was actually very new to that subject when I started it, that I had learned were out there, to sort of how to dramatize the gap between public perception and scientists instead of just telling people about it. So there are these polls that were out there. People had written about this, and I actually I didn't think it was going to work. I called up. There was a little mention of it in another story somewhere that I read. That story had to do with papayas, but there was a mention about orange that the orange industry might, and this particular company might try to do genetic engineering to deal with this terrible disease because there was no other cure. They had found no other way. I mean, there are like pretty awful pesticides actually were being approved by the EPA in order to just deal with like an emergency approval of pesticides. They couldn't find any natural resistance, so they were trying to develop this disease-resistant orange, and they had some modest success with the spinach gene. So I called up the CEO. I called the company, and he called me back.
Is that unusual?
I thought it was going to be hard. Well, and I shouldn't make it sound so easy. He called me back, and he said, this is a very touchy subject. I don't think I don't know, but I am open to you coming down and talking to me so long as it's completely off the record. So that is not something that a reporter would normally do, actually, because we like to have things on the record. It's also, the Times, as Donald Trump has called it, the failing New York Times. We do need money. We can't just afford to spend money on travel and my time. But we have, I have to say that we've had 41,000 new subscribers since the election. We put out a press release today on that, so we are not failing. But anyway, my point is, it was a risk to take, that risk to go and spend 3 days on kind of a flyer. Would he agree? But he decided to cooperate.
What else is fun about reading your work is because you write about science and you've dived into plant science, I recognize people that I know. The papaya guy, Dennis Gonzalez, terrific guy.
Yes.
One of the characters, one of the scientists in your citrus greening story is the guy who I worked with in the first laboratory. He was the guy who introduced me to science.
Was it Bill Dawson?
Bill Dawson.
Oh, I loved Bill Dawson. I spent a lot of time with Bill Dawson. He's a character, I think you would say.
Well, I kind of wish that there were more people doing what you're doing, but on the other hand, I kind of wish not, because you're doing something really special.
But wait, speaking of plant science and your entry into it, and here we are at the Danforth Center. So although I've written, I jump around from subject to subject. So I spent some time in the plant science world, and then I was on to a completely different subject, neuroscience, and now I'm doing something about math. But I come back to, I'm drawn back to plant science, but I have a lot of questions about it. Well, the one being, right? So why is it taking so long for you to change the world again, right? Like, we had the Green Revolution. Here we are. This is the biggest plant science center in the world. Is that right? In the world?
Independent Plant Science Center, nonprofit.
Nonprofit in the world.
Why is it taking so long?
So, yes.
Well, I think there is a little bit of a misconception. There's a misconception, and I hear it quite frequently, that the Green Revolution resulted in XYZ, as if it stopped.
Okay.
The reality is that we've made continual progress in plant science. And plant science, as you know and everyone knows, is not just GMOs. There was a lot of plant science before molecular biology, and there will be a lot of plant science in the post-GMO world, which will be here probably sooner than we realize because of other technology that will supplant it. But
you got to tell us about that.
Let's just consider what's happened since 1960.
Okay.
And I'm pulling that out of the air because that's the year I was born. And I've got that as a point of reference. We've doubled productivity, and that productivity has pretty much been a steady increase since then. The work of the Green Revolution was really middle of the century. It fed forward for a long time, but science and technology added to it, and that productivity.
How are you measuring productivity?
It's
by yield?
How much do we get per acre, per amount of input? So how much water, how much fertilizer, how much labor?
Okay, but we need much more, right? Why I'm drawn back to plant science is we have a rapidly growing population in a rapidly warming world, and everybody, I'm concerned.
That's right. How do we feed the current? We have to remember there's 800 million people who are undernourished or food insecure. So it's not like we're starting, we're good now, and we got to meet a future challenge. There's a today challenge. And it's not just how do we feed another 2.5 billion people, it's how do we do it without consuming all the water and suffocating the planet with greenhouse gases.
Right.
That's the reason we're here.
But genetic engineering is sometimes held up as, we need this in order to make bigger gains, or, what is it, do you think we're just going to keep seeing that slow increase, or? I
think we have to. If you look at the past as a predictor of the future, you can reasonably say if we keep the pedal to the metal on science and technology, a different type of science, we can keep that incremental gain in productivity going. However, that's the whole point. It's the science and technology today is going to be insufficient in 10 years, 20 years, 30 years. So there's going to be this continual need for innovation just so we can produce without using any more water than we're producing, or without going onto more land, or without losing more soil, and getting more CO2 in the form of carbon in the soil. There's so many challenges that are science and technology challenges. The 21st century grand challenge, though, why am I doing all the talking?
This is right.
The 21st century grand challenge is doing all of that, but in a way that is more nature compatible.
Okay.
That's a more simple way of saying what the grand challenge is. Because we can produce twice as much food. We could do it today. We would just use all the water. We'd mine all the phosphorus. We would put nasty nitrogen-containing gas into the air because of all the fertilizer. We'd run off, it would be a disaster, and it wouldn't be sustainable. So the challenge is new science, new technology that's nature compatible. That's it.
That's the challenge, but how are you going to meet the challenge?
Well, some of the people you talk to today are going to contribute to that. It's going to be.
I did meet some very impressive people today.
It's going to take changes in consumer habits, probably. Maybe training the world to eat less meat, who knows? The problem there is, as living standards in places like India and China increase, and sub-Saharan Africa, as living standards increase, they're going to demand more protein in their diet.
Right.
So are we going to say, no, you can't have meat because it requires too much grain? This is going to be huge,
pretty
huge
paternalistic. This is actually something I feel like I should know, but what has been the trend in public funding for plant science over the last couple of decades? Are we funding it?
No.
In the
Biomedicine gets all the glory
Yeah.
and all the funding.
I know that I've heard this. Plant scientists
Yeah.
feel like they're like the Rodney Dangerfield of science, right? That you don't get, right? I've heard this from other plant scientists.
Fortunately, there are data that back it up. I can give you here's a good illustration. I got to get the questions back to you. What do you think, among the top 3 funding agencies for the Danforth Center, what do you think they are?
USDA.
I'll just stop you right there, because I was hoping you would say that. Again, we didn't rehearse any of this. USDA, you have to go down to like number 8 on the list of funding sources.
Of government agencies?
All funding sources, including private foundations. You have to go down to number 8 because the USDA puts only a sliver of funding, of the overall funding pie for plant science, into the system. So if the USDA isn't recognizing yet the need to invest to meet this big grand challenge, who is? Turns out our top funding agency is the Department of Energy.
Oh, well, if you're getting money from them, then you're okay.
Well, but it's for a specific
It's not for
slice
plant.
of the need to make bioenergy more sustainable.
I see. So you're saying there's another area.
National Science Foundation is number 2. Bill and Melinda Gates Foundation is number 3. Which of those organizations is a plant science-centered organization? None of them. So that's in contrast to, say, the National Institutes of Health. And I've got a bunch of questions for you.
All right.
So,
Bring them on.
I think you get the point.
Yeah.
It is an underfunded field. We compete very hard for money, and we do pretty well because of the really good people you met today. But it's a challenge, and it's overall, it's a field, it's a collection of fields that has urgency in the world that is underappreciated, underrecognized, and underfunded. Here, let's go on to another topic, and I see the tweet wall is showing up. I'll sample things off of the tweet wall as we go along. I want to throw 4 terms at you. You've hit all of them, I think, except for one. 3 terms: climate change, evolution in the schools, vaccination, and GMOs. Those are when I think about disconnects between scientists and established science and the public, I think of those 4 topics.
Right, yeah, I think that's
Maybe
fair.
some bias with the GMOs there because we think about it sometimes, but the anti-vaccination movement is really alarming, and I had not heard about the 4 mumps cases at Harvard. That's really scary. Let's talk about why is there this gap? You touched on it a bit, but let's dig into this thing called the science confidence gap.
I didn't know it had that official term, but okay. Yeah.
There's a lot of terms out there. But when you look in the literature of who's studying this problem, you see this term science confidence gap, and it has to do with trust in science and trust in scientific institutions. I want to understand why these gaps exist, and ultimately what we can do about it. Is it all politics?
I tried to mention a few of the reasons I think about in my talk. I do think that there needs to be, I think that science still has this, it's almost a cliche, but the scientists exist. Look at this beautiful place that you exist in, right? It's like a cathedral of science, and I can see why people want to work here. But okay, just to be fair, you have opened it to the public tonight, so that's great. But I feel like there are all these areas of, even geographic areas where scientists work and they don't connect to the public. They go to, I sometimes attend scientific meetings. Scientists like to meet in very nice places, tropical preferably, but the public isn't invited. Your published papers are behind paywalls, even though often they're funded by taxpayers. The
Most of ours
research
are not.
Okay, well that's good to know. Is that true? Okay.
We aim for open access journals,
You do?
and when we do have a paywall journal, you can usually pay your way around it. It's a racket, frankly, on the part of the journals. We end up
you
paying.
Can pay. I see.
We'll pay $1,000 or $1,500,
I see.
and they will put it outside the paywall. So we encourage that type of behavior.
I think that's great. Not that many people do.
but that doesn't. But putting something outside a paywall gets a real small segment
narrow.
of
I
the
agree.
public,
Yeah.
because most are not. More people are learning science from you, or as you mentioned, the internet. Maybe even more now from fake news sites than from you and the New York Times.
And from their friends and from their family. I mean, I think that research on science communication, which has become kind of a little area, cottage industry of research itself, does seem to indicate, I'm not a complete expert on it, but it does seem to indicate that people are influenced, even if they are told by an authoritative source that they do trust. And I actually think people trust scientists more than we think. But they may not change their views unless somebody in their social circle who they respect has those views.
So the power of Facebook or the power of your...
But that's still a question of communicating. I mean, so that means that doesn't let scientists off the hook, right? I think that means, okay, scientists connect with one person. It actually gives, I think that little bit of research is often read as a kind of a cop-out. Well, there's nothing we can do. The public, no matter what we tell them, they're not going to believe us.
Why don't they understand?
Yes. So, but the point is that if you reach somebody who's kind of an important person in a circle, then you've reached a lot of people. So you just have to reach that person.
This literature about science communication, I've gotten into just a little bit. I'm paraphrasing something that I read from a real peer-reviewed journal article. Despite the struggle by the public with science, understanding more about the mechanisms underlying a scientific result increases the probability of acceptance of that result. That came out of a study that was done in Idaho, which has a conservative lean.
That's
and
interesting.
it was kind of focused on how do people with a conservative bias, which there's been a negative association over the past 30, 40 years with conservatism and acceptance of science, particularly when it gets into the realm of policy, science that impacts policy, like climate change. But this was looking at, you take an audience that has kind of a political bias that influences their science acceptance, and it was saying that if you explain it, if you have the opportunity to explain it in detail and peel back the layers, if you have the opportunity
right, that's so
to do
encouraging,
it,
right? I want to see that study.
Well, okay, so does that mean that, so at the level that we're talking to the public, should we be talking about type 3 effectors and persistent homology?
I mean,
should we be talking about microRNA binding to PAS domains?
I think that there should be some forum, right? Why shouldn't there be some forum in which I've always thought that, and I think that some institutions do this, where scientists have to write a lay person's, something in lay language to explain a paper's result. I mean, something like that, because of course it makes total sense that people would want to understand. I mentioned that I posted on my own Facebook, tell me your pet peeves about scientists, and one of my friends said, I hate it when they say the science is done. They just say, just accept it. It's the word of the scientist, right? So there should be forums in which scientists explain in more detail.
So here's a question on the tweet wall right now related to this. What can be done to remedy the lack of science literacy in the US? And I'm going to turn that question around and say, how much is lack of science literacy contributing to the problem versus there being an intrinsic receptivity to science, and we're just doing a really bad job connecting it to their lives.
Yeah, I really do kind of think it's the latter. I mean, of course, we should improve science education in the United States. Like, we should improve, reading education in the United States and math education. And I think it's really, I will just say, I do think it's really of concern that we have an effectively segregated school system in which underrepresented minorities get less resources, and so they are getting a less good science education than other people. That's a problem. But I think that the public is probably more science literate than, and actually there's a National Academy of Sciences report out on that recently that says, actually we're not so illiterate, and we should be, it's what you said, it's about reaching people and reaching people in the right way.
I have a friend named Victor Ambrose at the University of Massachusetts, great guy, and he gives a talk to public audiences, and he starts it with, there's a scientist inside of everybody, and we tend to snuff it out later. But when kids are rolling around pulling bugs out of the dirt, they're sampling nature, they're sampling their environment, they're actually doing a little bit of science there.
Yeah.
And then we come and maybe through our education system, are we snuffing out the interest in the continuing education of science? Or do we squeeze the life out of it the way we teach it?
I think that if I look back on well, let's see, I have a 12-year-old daughter who is, she's learning science. She learned the scientific method. She's doing a science fair. I wouldn't say it's the most, I don't want to offend her teachers in public. It's not the most scintillating.
The cameras are rolling.
Yeah. I think we could do a better job, certainly, in science education.
So how much is the false equivalence problem propagated by journalists and not helping the public appropriately weigh what is good in terms of defensible and scientifically rigorous versus weak or fabricated even?
I think that there is I can be somewhat self-critical about that for my profession in certain areas. I think, though, I will say for climate change, for example, Times reporters who write about climate change used to do that, right? There definitely used to be, and probably for too long after there was a very clear, overwhelming consensus that humans are causing climate change, where we felt we had to say, but there are dissenters.
So now that line is going to be strong scientific consensus, but not everyone running the EPA agrees.
If there is an EPA, there may not be an EPA at all, but yes, strong scientific consensus, yeah, except for the government. But we still, my point is, though, that we haven't been doing that for a few years now. So I think that the media, and the same happened with evolution. I mean, there was sort of, there used to be this sort of sense, and I know that a lot of scientists resented that. I think rightly. I think that continued for too long, but we stopped. But so I'll throw it back to you, though, because it's when there is the public, I think has understood it enough. When there is this strong sentiment out there, in the public that there is a dissent, I feel like we feel like we need to acknowledge it in some way, and that our job is to portray the spectrum of public opinion.
Yeah. Well, that's a pet peeve.
I got it. Check.
Is science today too complex for traditional journalism? In other words, are we covering what we need to be covering well enough, or are we covering the scope of things that are important to society that are underpinned by science? Is it too complex? And is that maybe degrading journalism in a way, or forcing journalism to be too shallow?
Well, I think that the only danger, you should also be subscribing to the New York Times and other very well, I won't just say the New York Times. You can subscribe to whoever you want, but I think that the only danger there, no. The answer is no. It's not too complex and there are so many great science journalists out there now. I think more so than ever before, actually. So who are well-equipped and wanting to cover this stuff. It's a question of whether people, I mean, there is a question of whether people are willing to pay for news that is expensive to collect and produce. And so I hope that people realize that they can't get it for free.
But they can get their news for free. It's just maybe not real news.
Fake news, yes, exactly.
So as you look forward, and I was going to say in the years ahead, but really it's in the days and weeks ahead, because this is a real problem now. A great story just came out 2 days ago in the Times about the fake news sites and the problems Facebook and Google are dealing with to censor content that is determined to be fake. So how do you feel about that? Is it a threat to your profession? Is it?
Yeah, I think it's scary. I think that Facebook is look, we all know it's a very powerful entity right now because a lot of people get their news. A lot of people come to the Times. The way they get their news from, they don't go to our website anymore. They click from Facebook. Yeah. So, Mark Zuckerberg has said he does not think Facebook is responsible. I hope that he rethinks that a little bit.
I think he's evolved over the past week in at least his public comments about this.
He seems to be soft.
We're just about out of time, but I have one last question.
All right.
What story that you've covered most surprised you?
Ooh. Most surprised me. Gosh, it might be the oranges story, actually. You made reference to it, and I didn't get to go into it so much. But it surprised me because I started looking into, as I said, I hopped from science subject to science subject. I'm not necessarily the deepest expert on genetic engineering, but I really immersed, and I thought, oh, food. I should write about the intersection of science and food. And I started looking into genetic engineering, and I didn't know much about it. And it really did surprise me that there was a clear sort of cultural narrative about genetic engineering that, and its danger to one's health that seemed to be unsupported by science.
We're out of time.
All right.
This could go on for a long time, but Amy Harmon, thank you so much for coming to the Danforth Center.
Thank you for having me. It's been fun.
And thank you for being, in my opinion, the leading interpreter of science for the public writing today.
It's very kind of you.
Keep up the work. Don't let the internet get you down. Thank you all for coming. The comments and the conversations that we have really are geared toward you, our supporters, the public, the people from our schools, the teachers, the students. If this is your first time here, please come back because we have another year next year of really interesting topics between food security in St. Louis to innovation in this community. It's hopefully you get the point. This is a little thing that we're trying to do to bridge this gap. I hope it's successful, and if we have guests like you, we're going to succeed. So thank you all for coming, and thanks again, Amy.
Thank you. It's a pleasure to talk to you.
Thank you.